Should I share my screen now? Or
Yeah.
Not now. Okay.
Firstly, I will introduce the session and you from me.
Yeah.
So, 今何人ぐらいいますかね？
今0。あ、嘘。これ私入るとこ間違ってる。ちょっと待って。
30人弱、28人。
20人ぐらいで
じゃあまあ、ぼちぼち前説から始めていきましょうか。
そうですね。ちょっと遅れて入ってるはずなんで、もう始めてしまっていいと思います。
はい。それでは、JJUGナイトセミナー4月 Objective Functions を始めたいと思います。で、今日はワンセッションだけアベルトさんに、話してもらいたいと思います。で、なんか若干そのファンの音が定期的に入っちゃうみたいなんですけど、まあ、あまり皆さん気になさらず、はい、セッションを楽しんでください。で、また例によって質問は YouTube のチャットの方に書いてもらえれば、後で拾って回答したりしますので、ぜひぜひ皆さん書いてもらえればと思います。はい。じゃあ、そろそろ始めましょうかね。人も大体落ち着いてきましたかね。
そうですね。ちょっと続々と増えていますが、だんだん、落ち着くと思いますね。このまま始めてしまっていいかと思います。
はい。それじゃあ始めたいと思います。So, Robert, please start your session.
Okay. Okay, let me share my screen.
Yep.
Okay, please start.
Okay. Can you see everything okay?
Yes, it's okay.
Okay.
Start.
So, はじめまして、Uberto です。The talk, I will do the talk in English, but if you have some question, I can understand a bit of Japanese. So the talk of today is about from object to function, and it's about a topic that I'm very passionate about. And by the way, I'm sorry, but the noise of my laptop the fan of the laptop just got very noisy, and I needed to change it, but just happened this weekend. I couldn't get the replacement. I'm sorry. I hope you can still hear me. Anyway, let's proceed. So, but first, I'm now living in Itoshima. I moved from London to Japan. So if someone of you drop close by to Fukuoka, just let me know and we can maybe organize something on the beach if it's summer. In this moment, it's very cold, but I hope it will get warmer later. Actually, it got very warm in summer, but there is the sea and it's a very nice place. But let's start with the real talk. I wrote this book about from object to function. The book will be you can buy from the publisher in ebook edition, but it will be printed in paper soon. I don't know. Maybe at some point it will also be translated in Japanese. I don't know. I hope. But why another book? And the reason that I wanted to write this book, because there are many books about functional programming, but they are mostly talk about functional programming in a kind of abstract way. I mean, it's good to introduce functional programming, but sometimes they left something harder to understand. How to use functional programming in day-to-day. So this book is about how to write a full application. So thinking about testing, domain-driven development, event sourcing, CQRMS, architecture, everything, how we can do this in a functional programming way. And the point of functional programming is not just to use it because it's cool and it's a new hype, but because we really want to get a benefit on productivity. So functional programming, yes, but in a practical, pragmatical solution. And in this talk, we will talk especially about exception, log level, and how to do loggings. And all this is a courtesy of functional programming, whatever it is. But what is functional programming actually? It's a good question. And I think the answer is that functional programming is just a tool to do a job. It's not an end in itself. But if we look at Google, we can see that there is a lot of definition of functional programming. And there is a lot of blogs that talk about functional programming. But there are some misconception that I wanted to put it right. Functional programming is not just using a list map and some lambdas in your object-oriented application. But on the other side, it's not true that you need a special language or a special library to do functional programming. You can do with whatever language or whatever library you have. And it's also not true that functional programming is not clearly defined. Actually, functional programming is very clearly defined by this gentleman, Alonso Church, that define this lambda calculus, which is a mathematical tool, before computers were invented. And functional programming is a way to try to implement the logic behind the lambda calculus, what is called beta reduction in technical terms, in our software. And doing this, we will reap the benefit of mathematical composition. In short terms, let's say, we can become more productive and spend less time trying to debug our program. At least this is the aim. And to use functional programming, we need to use a function, as you can guess from the name. And they are not just any function, but we need to use pure function. And what are called pure function have these two rules that they have to follow. They cannot use any other input than their argument. So a pure function cannot access to global variable, singletons, files, external resources, or anything like that. And it cannot produce any other output that their result. So a pure function cannot change, write on the system, or change some global mutable state or anything like that. The only effect of a pure function is its result. And if we follow these two rules, we are following what is called referential transparency. So our functions became kind of transparent. So you can replace a function with their result, basically, at the end. And if we start, I'm doing very quickly now, just to give you an idea what is functional programming. But of course, in my book, I will discuss this topic much later. But a web server, for example, is just a function in this perspective. It's a function that takes a request, extract some information from the request using the path, the header, the query parameter, whatever. For example, in this case, extract the user and a list name for an application that needed to return it to the list. Then somehow the application So this is the function one. From a request, an HTTP request, extract user function name. But in function 2, from the user list name, somehow extract a full to-do list. So, for example, accessing a database or doing some other external state retrieval. Then there is a function 3 that transforms a to-do list in HTML page, and a function 4 that put the HTML page inside an HTTP response and return to the user. So the whole concept of a web server will use just this metaphor. It's not really a metaphor. It's actually just a function, and a function that is composed by other functions. So in this perspective, we can see how there is a library that I also talk about in my book, which is called HTTP4K, and that does exactly this. So this is the code. That you can see, and the code, by the way, is a Kotlin code, but I hope it's not that. Even if you're not really used to Kotlin, it's quite similar to Java code. Basically, where you see this double colon is just a way to reference a function. So in this way, basically, we concatenate 4 functions. And so we can translate the diagram on top in this code, very simple. And this is all our HTTP server, let's say. So we don't have the concept of model, view, controller, DTO, all the other stuff that we are using when we are in object-oriented paradigm. So this idea of functional programming is mostly about using function and composing function one of another. And in my book, I call this way of designing application thinking in morphism, because this transformation are also called morphism in functional programming. But okay, so we talk about what is a pure function, but what about impure function? For example, impure function can be accessed in the file system, writing on the network, but even just reading the system time is an impure function. So, of course, our program needed to do impure function. So how can we put the impure function inside the pure function? So how can we combine them without losing the benefit of functional programming? And in a way, this is the biggest problem of functional programming, the things that is most challenging, and where basically several solutions exist, and you can choose the correct solution on your problem. I will show you here just 2 solutions. The first is very, very simple. So use just a lambda. So you have, for example, a first complex logic, which is a logic to add 5 to a number, which is not, I mean, you can imagine that it will be something more complex. And during this computation, we also do some logging. We print the result. And doing this kind of logging, but it can also be like connecting to web, remote web or stuff like that, we make the whole function impure. And this is something that we don't want in functional programming. So we wanted to keep the impure part, the side effects part, as small as possible. And this simpler solution is just inject. So the second implementation basically is equivalent, but we will get the logger as a function. So we pass the function as a parameter of our function. And we call that function. And it seems like, okay, what's the deal? It's the same things than above. But it's not. because the second one is a completely pure function. So complex logic is pure. The log may be impure, but we just needed to put an impure log when we compose the function, like for example, in the main of our application. So 90% of our application will stay pure, and the impure part is very minimal. Instead, in the above case, everything became impure. So you cannot reuse this complex logic impure function anywhere else because there is this impure part. Instead, the second one we can reuse, we can compose, because depending on what we pass as log, it may be completely pure. So this is the kind of the easiest strategy for simple things. But when the going stuff, we needed to do database transaction and stuff like that. This simple solution became quite hard to use. And so how we can do this? We can mark the impure parts and make them type safe. And what I mean with the type safe is something like you cannot call an impure function without having a special type that wrap it. Otherwise, the program won't compile. So this basically gives us this safety that if everybody was following the rule, our program, we can decide in our problem which are the functional parts and which are the impure parts, and just putting together, trying to minimize the impure part, but without losing the possibility of doing a complicated operation. So how this is possible? It's possible doing something that let's call a transformer. I mean, they call the real name is functor, but you don't need this you don't need to learn this fancy name unless you really want to. So let's consider a generic type that can be transformed by a function. So any possible type that you want. For example, we have this box type, which is a generic on T. And the T can be anything. So we can instantiate a box of integer, a box of string, a box of date, a box of type user, a box of any type that you want. But with the second, with the transform function, the method, we can transform the box from one type to another type. So even we have a box of integer, with the function from integer to string, we can transform it to a box of string. If we have another function from string to date, we can transform it to a box of date. So this kind of, it's a generic type, but can be transformed. I think it's a very simple concept, but it's very powerful. And it takes some time to be used to it. But of course, now I can imagine that you have a question. What's the point? I mean, why bothering about having the box at all? Well, the point is that in this way, we can keep the value without letting the people to extract. I mean, we can keep using the value without letting the people to extract it. And when I say people, I mean the program. And the reason for this is that we wanted to do some special effect, some impure effects on the value. But in this way, we can apply the effects in a safe way. And this is what is called like functional effects. Now, the most useful of all functional, probably, I mean, in my opinion, the most useful of all this transformer, of all these functors, if we want to use the proper name, is called context switcher. And basically, it's a box with a function inside. Now, at this point, I think you maybe start wondering what I'm talking about, because it starts becoming a bit harder to follow. And I think you may want to look at the slide later. But if you follow a bit with me, the idea is that you have a box, like the box that we had before. But instead of putting a string or an integer, we put a function in a box. So if we put a box with a function from int to string, in this way, we can use the box to do other operation. And specifically, using this context reader, we can implement a cache, something that read a file, that's something that read from internet, something that use a database or other things. It's called a context reader, but it's not about reading. I mean, you can also use to write, but because the idea is that it get the context and extract and read something from the context. So for example, in this way, we have a reader that this is a possible implementation in Kotlin of a context reader. And we can use it to read from a database. So we have a function read list that starts from an ID and return a context reader with basically a database as a context and the to-do list as the object that we're going to read from the database. And maybe you can start seeing where we are going to. So we have this read list that return the context reader. That being a transformer, we can transform it with a function that transform the list in HTML page. And that function is a totally normal, pure function that doesn't know anything about the context reader or database. It just takes a list and transform in HTML. But because we apply in the transform, the function will be applied to the list that we have had from the database. And so at the second line, we still have a context reader. How we get rid of the context reader? We get rid with this run with or execute, also it's also called, which is basically is a way to say, okay, this is the impure part. I will use a database connection and I will transform everything else in give you the actual result. And you can see that basically this is the powerful way that functional programming handle impure effects, because everything happen only when we want with this run with. Everything before the run with is completely pure, and we limit the impure part just at the minimum, which also in a few program it will be some thing in the main, only the main basically have the impure function that connected to the database. All the rest of the program can stay completely pure. And you can say, yeah, but actually there is a problem if we compose it one effect over the other. So let's say that instead of a read list only, we also have a write list that work more or less in the same way. We give a list and we got a context reader with the idea that we wrote the list to the database. And let's say that also we have a rename list that just change the name of the list. So another completely pure function. So we apply the first, so we read the list. So we get a list from a list ID. We transform the list with a new name. So whatever it was, now it has a new name. And it's still wrapped inside the context reader. And then we transform again to write. But then there is a problem, because we had a reader of a to-do list. When we transform with the write, which is a function that returns a new context reader, we finish with a context reader of a context reader, which is not something that we really want. We really want a single context reader, otherwise it becomes very complicated. So what can we do? So let's see the same things with the box. So if we also have a function that creates a box from an integer. So we have the boxit, the function boxit, that apply to 5, it returns a box of an integer. Then we transform again with a boxit that multiply the value by 2. And then we have another box of int, which is again something that we don't want. So to solve this, we have something that is called the monad, but we don't need to call it monad, because there is this idea that monads are super complicated to learn. But this is really not the case. I don't think that is real. If we forgot about the name of a monad, what we have just is a box of a box, and we want something that simplifies that. And just to give you another example, it's a bit like a Rubik cube. If you know, you can keep transforming, but it remains the same. So this is more or less, if you wanted to do a simile, how monads work. It's something that it can be transformed, so it's a transformer, but it stays the same. It doesn't become a box of box, it stays a box. And the operation to do this, it has a different name. It's called a flat map in some library and stuff like that. But let's call it a bind, because it's kind of bind two contexts together. And it's just a bit of little bit of code. That basically means that with the bind, we can apply the write list to our context reader, and get in return not a context reader of another context reader, but a simple context reader. So bind basically is this operation of transformation without changing. Changing the result, but not the type. It will stay a simple context reader. And in this way, we can rename the list, write the list, run without losing the context reader, transform the list, and then giving the connection, get the final operation. And that's it. And this is all this monad thing, which is not really something that you should worry about. But the functional dilemma, let's say, is this one: a lambda or a monad. And my opinion, if a lambda works, just go with the lambda. But if you want to have a complex operation like a database or some other operation that you needed to keep a state between the single operation that we are working, then a monad is not that it's a bit more complicated, but it's not that hard to use, and you still keep everything completely pure. And so, since this was a talk about exception, let's talk about exception now. So we know that in Java we have the checked exception, which was a good idea, let's say. But they are quite verbose to handle, and we kind of force us to handle the result twice, because we need the normal result plus handling the case of an exception being thrown. So at the end, very few people use the checked exception in Java. Not even the JDK now is using much checked exception. But we got left with the problem with unchecked exception that can break the flow unexpectedly, and if we don't correctly throw a catch, they can break the code even where, for example, it wasn't an error that should have stopped the application, but it could have been easily handled. But with the unchecked exception, we have no idea that there was this possible problem. I mean, typically, you wanted to transform my data, and you kind of, okay, I mean, if the data is not a valid data, just figure out some sensible default. Instead, you got an exception that completely stops your application if you don't catch, which is kind of unfortunate. And also, we lose the original context. When we got the exception, we don't know exactly why it has been thrown. We know why it's been thrown, but we don't know what's happened before, basically. And maybe we got the actual data that was not a correct date. Few lines up, and we have no idea where this came from. So what is the functional programming response to this? It's another kind of monad, which is called either, but it's basically a result that can be either a success or a failure. And the nice things about this is that we can, our context reader basically can handle this failure or success. And we can say, for example, if there is an error, just add this additional information to our context. For example, when the origin of the error was trying to rename stuff. And if there was also an error, it will stop basically to proceed to the next step. And it won't write the list if they wasn't able to read the list first, for example. And okay, this is this example I took from my repository where I put some library that we are actually using in production, so they are quite solid. But of course, it's just well, so you can look if you are interested in this topic. Everything is in Kotlin, by the way. Yeah, and finally we have it to login. So we know that. Sorry, let me first introduce. We know that what is functional programming. We kind of saw what are monads, and now we wanted to see how we can use this to log the state of our application. And there is one kind of rule, and that Kirk Pepperden, which is one of the most knowledge people on the JVM, how the JVM works and how to debug the JVM, used to say, I mean, log as much as you can when things goes wrong, and a little as you dare when things go well. So we want a lot of information when there are errors, but we don't want to have many logs to explain us that things go well. Just, for example, the logs that are useful for our KPT or our indication. But when things goes wrong, when we have an error, we really wanted to know as much as possible about all the possible conditions that what is the context of this error. And using functional programming, this became quite easy because outcome, this monad with the result, we can put all the information that we need inside. So, for example, if we have the logger, we can add the context with the full user. And, for example, the user can be related to the reason why list or name failed, or we can add the date, even the machine, anything that can be kind of useful when there is this failure, any related information that we can find useful, we can put inside. And in this way, this will be only logged when there is a failure, basically. Or when there is not a failure. I mean, of course, we can decide what to log in each case because we have the result and we can put the context only for the failure and the positive result when everything is okay. And when I try to use this, usually the typical question is, okay, what about the debug? Because we kind of covered what is done usually with error statement and for the error case, and kind of usually info statement for the positive outcome. But if we wanted to put a simple debug, like I did here, I did that here, how can I do this in functional programming? Well, the answer is that basically you don't. And to see why, let's see how usually debug are used. Well, I don't want it to be too, I mean, of course, if you really want, you can, but you probably don't need to. And you should reflect if you really need a debug statement. The bugs are usually used for temporary checks, like we are debugging, we are trying to understand what's happened, so we put some debug here and there. But usually this we can just replace with some print line or stuff that are clearly breaking the functional purity, but are just temporary. We are not going to release this stuff in production. The other reason that people use debug sometimes is for some matrix or kind of interesting information that you wanted to write or not write. I mean, to control from some configuration. Sorry. And I think if you really want, if you really need matrix, you should use a matrix library. There are OpenTelemetry or stuff like that. There is a very good library which are much better controlled than just using random debug statement. And the last point, which is interesting, is we usually need to debug kind of information that are not interesting, which is something that we don't really care about, but we wanted to know, like something like I'm here, this stuff happen, or stuff like that. A small sub-step which are not interesting per se, but we only care about because if something bad happen, like an exception, we can check which of these uninteresting stepping stones have been written last. And so we have a kind of idea, okay, maybe this is where I should look like. But the point of using outcome and these functional things is that we don't need this step anymore. And we can just rely on the information that we have at the end, because we are sure that everything will be wrapped inside our result at the end, our outcome. And of course, another consequence of using functional programming is that we shouldn't use a static log factory or log singleton, as it's kind of widely not so best practice, at least in my opinion, in a Java program. Instead of using log levels, also you notice that at this point we don't have log levels because we have the success, we have the failure. You need if you need a matrix, you need a matrix. and you don't have the bugs. So basically, we have get completely rid of the log levels. But on the other side, we can log structured data. We can log entire object hierarchy data, everything that is interesting when things goes bad. So when there is an error, we have a much better context information. I also noticed that with this approach, we don't have a configuration file. We don't have to configure log4j with an XML or stuff like that, because everything, there could be configuration file, of course, but the most of the logic is in the functional composition itself. Sorry. So the end result is that we can have a better performance, and our program will be easier to debug and easier to test. And this is the kind of error that we aim to. So we can get an error on operation with the specific user and a message from the Postgres driver. And we have the full HTTP request that created this error. And probably looking at this error, this is almost a real one from our data, from our production. You can understand exactly what's happened, and for example, that there was a database migration that didn't work or stuff like that. But this is much better than having to look at the logs in the standard format and trying to understand exactly what's happening. This is my experience, our team experience. I've introduced this in several teams now, so I'm quite confident. And of course, if you like this stuff in the book, I explain better and with more example. But the last bit that I want to talk about is about hexagonal architecture. I'm very fan of this way of separating the domain, what in this diagram are domain A and domain B. In two, let's say that we have two microservices or whatever, that do several things. And they have the domain, and they talk each other with the HTTP, and they have a database. So we wanted to keep the domain separated, and functional programming has nothing against it. On the opposite, it's very good also in the functional programming to separate the domain function from the adapter, the technical layer function. Now, where to put the logger? Now, the interesting thing is that you can put the logger completely on the adapter and leave in the domain without any logger, which maybe sound strange, at least it was for me. But actually, it's a good idea, because the pure function itself, if your domain is completely pure, you don't need logs. I mean, when you have a pure function like transforming XML in JSON or doing some calculation, you don't need the intermediate logs, because the operations are quite straightforward. I mean, if they are well tested, they are quite consistent. But you wanted to log everything that goes in the model and go out of the model. So in the diagram, and anything that goes to the database, anything that goes in from the HTTP layer or go out from the HTTP layer. So all the things that happen at the gate of the domain you wanted to log. So you can see what's going in the domain and what came out. And if you put the log outside the domain, you can usually do this with a kind of a generic not really generic, but a kind of a templating way that avoid the duplicate, avoid to having multiple log for the same things, or forgetting completely to log a specific code. And you can just log all the codes in a single with a single functional code and just compose them. And it also makes it much easier to test because you only need to test the result at the end of the domain or the adapter itself, rather than checking the domain but also its log, which usually nobody really tests the logs, and that's usually another problem because sometimes people forget logs and you only discover when things goes bad. So this is all. If you're interested, you can follow me on Twitter, Medium, and also I started a little YouTube channel, but just last week, so I'm experimenting with the YouTube and the ChatGPT, by the way. So I really hope that you enjoy the talk. And if there are some questions, I will try to answer them.
Okay. So I have one question.
Hi, yeah.
I couldn't tell how do you suppress logs. So I mean, you use the log context or some logging function, but I couldn't catch that how I can select the logs. I mean,
Yeah, that's
yeah.
Yeah, I mean that's the point that you don't suppress logs. So I mean, if you really have a reason, of course you can, but you don't have the normal reason to configure the log level, which is usually you don't want. I mean, having two logs become slow or stuff like that, or too confusing, because you have the kind of. I mean, metrics are apart. You should remove a metrics from logs anyway. And so in the logs, you should really only have errors and just a little confirmation when everything goes well. And so in this way, you really don't want to suppress error logs. And basically, you don't have a debug log, so you don't need it. Usually, you don't need to configure log level at all. Which is kind of surprising, but it works.
Yeah, I see. Actually, nowadays, log is not included in the business domain. Yeah, I don't want to write logging code into my business logic. So yeah, there are some necessary logs for business logic. I mean, some transaction starts or finished in error. That kind of logs may be necessary for business operation, but yeah, most logs are for developers or debuggers. Yeah. I think they should be distinguished or written in other ways.
We also discovered that most of the logs are the technical adapters. I mean, database, HTTP file, whatever, and you only need log on the domain only at the beginning of the result. Like we have this next, and this is the result, but you don't need log inside the domain.
Yeah. I see.
Of course, there could also be exceptions, but generally speaking, it's a good rule. Yeah.
See. 何か他に質問ある方はいらっしゃらないですかね？
今のところ何も来てないです。
ないですかね。So, no questions so far. Okay, then, yeah, let's finish this session. Thank you very much. Thank you, Alberto.
Thank you very much.
Thank
Let's,
you.
let's see you soon.
では、今日の、JJUGナイトセミナーはこれで終わりたいと思います。じゃあ、前さんなんか最後告知
はい。今月の告知はもう CCC 一択なので、CCC と J 温泉ですね。J 温泉。そう。間もなく J 温泉締め切り走りますので、J 温泉っていう、英語でアンカンファレンスを温泉でやるっていう、日本なのか英語なのかよくわかんないイベントがあるんですけど、そのイベントを参加したい方は、後で JJUGのツイッターでURL を送れると思いますので、皆様ぜひ参加してみたいなと思う方は参加してみてください。So, can you join the J 温泉, Uberto san?
Yeah, I will join with my family, also my daughter and my wife.
Thank you. そう、家族連れでの参加も OK ですので、お子さんとかご家族旅行とともに一緒に合宿したいわって方いたら、ぜひご参加ください。リアルの上さんにも会えるかと思います。あとは、その J 温泉が6月の
1日から3日。
1、2、3ですね。1、2、3。木、金、土やって、その次の日曜日は JJUG-CCC です。で、JJUG-CCC 今年はオフラインでやりますので、ぜひ新宿まで久々に行ってみんなでワイワイしようかなと思う方いらっしゃいましたら、ぜひ今からでも遅くありませんので、登録をお願いいたします。オンライン配信はほぼない。一部あるかもみたいな感じかもしれないんですけど、本当にごく少数という話なので、ちゃんとセッションを聞きたいのがあるなって方は、ぜひオフラインに会場にお越しください。懇親会もありますという形になっておりますので、ぜひご参加お待ちしております。なお、JJUGナイトセミナー5月分は絶賛今企画中ですので、いつになるかもまだ決まってませんが、やりますのでお待ちくださいという形になっております。はい。私からは以上です。
はい。それでは、今日の JJUGナイトセミナー、これで終わりたいと思います。So, we will finish this JJUG night seminar this month. So, thank you, Bert, and attendees. Thank you very much. Thank you. Bye.
Yeah. Bye.